This will be the last video on linearity property of the system. In the previous 5 lectures, that is from lecture 2 to lecture 6, I've taken up some couple of systems to check for its linearity property. Now I have some other systems which we can check for its linearity property, which I'm going to list here now. Okay, the first system is y of n is equal to x square of n minus 1. Okay, I hope you can understand the system. What's happening to the system here? If you feed x of n, what is the output I'm getting as y of n? It squares this given signal x of n and shift that signal right by one time. In this case, by one sample. This is what the system is doing. Second system, y of t is equal to x of t into sine 60. Here, if I feed x of t to the system, what is the output I am getting? For whatever the signal x of t you feed, for that sine 60 is getting multiplied. Okay. And the third one, y of n is equal to x of n plus n times x of n minus 1. Here in this case, if you feed x of n to the system, so for that signal x of n, one more signal is getting added, and what is that signal? N times x of n minus 1. The signal shifted right one time, and for that n is getting multiplied. Fourth one, y of t is equal to e power minus t x of t. So here, whatever the signal you feed, that is x of t, for that an exponentially decreasing signal is getting multiplied. Y of t is equal to x of t into cos of 50 pi t. Here for the input signal x of t, cos 50 pi t is getting multiplied. One more signal, y of t is equal to t times x of t. For the input signal x of t, unit ramp function t is getting multiplied. Okay, as a practice problem, you just try to check for linearity property of this system. And before I end this video, there is a trick actually. In the lecture 2, I had taken up one problem called as y of t is equal to x of t into g of t, right? And I had taken one more problem in lecture 3, y of t is equal to x of t plus g of t. Okay, there is a trick here. As we know, x of n is the input signal, whereas g of t can be any arbitrary signal, right? Even here also, g of t can take any signal. Now, from the solution of this system, this was actually linear system, and this was actually non-linear system. Right now, if there is a system where the input signal is getting multiplied with some arbitrary signal, it is usually, most of the time, it's a linear system. And if you have a system where for the input signal is getting added with an arbitrary signal, and in that case, most of the time it is a non-linear system. You can check and verify actually. This might not work for all the system, but most of the time this will work. Okay, multiplied with an arbitrary signal, it's a linear system. Added with an arbitrary signal, you get a non-linear system most of the time, not for all kind of system.